Let's understand quotient rule of derivative. We have an expression y is equal to something by something form and we have to find its derivative. So whenever y is written in the form of a fraction, you can apply the quotient rule of derivative to find the derivative of that expression. So how does the quotient rule of derivative work? To find the derivative of y, we write y dash, which is the derivative of y. And now for the quotient rule, what does it do? It says the lower expression as it is. Here the lower expression is x plus 5 as it is. And the derivative of the upper term. The upper term here is x cube plus 2x square plus 1. So we will find the derivative of the upper term. The first term in the numerator is x cube. Its derivative is 3x square plus 4x plus 0. So lower term as it is, upper term derivative. Upper term was x cube plus 2x square plus 1. So separately apply the power rule. X cube derivative is 3x square plus 2 as it is, and x square derivative is 2x by power rule of derivative, which gives you 4x plus, and derivative of 1, which is a constant, it is 0. So quotient rule of derivative again, lower term as it is, upper term derivative minus upper term as it is, x cube plus 2x square plus 1, lower term derivative. So derivative of x is 1 plus derivative of 5 is 0, whole divided by lower term as it is and its whole square. So this is how the quotient rule of derivative works. And then we can simplify this expression. It is x plus 5 into 3x square plus 4x minus x cube plus 2x square plus 1. It is being multiplied by 1, so we will choose to not write it. Divided by x plus 5 whole square. So this is how we find the derivative of an expression which is written in something by something form, in the form of the fraction, by quotient rule of derivative. Let's apply quotient rule of derivative on another expression. We have y as x square minus 1 divided by x to power 4 plus 1, and we have to find the derivative of y. Again we can apply the quotient rule because this y is in the form something by something, or it's in the fraction form. So we can apply the quotient rule. What does the quotient rule say? Lower term as it is, upper term derivative. Upper term is x square minus 1. X square derivative is 2x by power rule of derivative minus derivative of 1 is 0. Lower term as it is, upper term derivative minus upper term as it is, lower term derivative. Now lower term is x to power 4 plus 1. X to power 4 derivative is 4x cube plus, and derivative of 1 is 0, whole divided by lower term as it is and its whole square. We have applied the quotient rule of derivative. Now we are going to simplify this. X to power 4 plus 1 into 2x minus x square minus 1 into 4x cube whole divided by x to power 4 plus 1 whole square. So this is how we apply the quotient rule. Let's look at another question. We have y as y equal to 1 over x cube plus 2x minus 3. You can look at y that it is given in the form 1 over some expression, or it's in the form something by something, or it's in the fractional form. So whenever we have a form of y like this, we can apply the quotient rule of derivative. So here when we apply the quotient rule of derivative, we get lower term as it is, upper term derivative, and since upper term is constant, its derivative is 0, minus upper term as it is, upper term is 1, and the derivative of the lower term, which is x cube plus 2x minus 3. Its derivative is 3x square plus 2, because x cube derivative by power rule of derivative is 3x square plus 2 as it is, and x derivative is 1 minus 3 derivative is 0. So we have this whole divided by lower term as it is and its whole square. We can simplify this expression. It gives us y dash. Since this term becomes 0, so the next term is minus 3x square plus 2 whole divided by x cube plus 2x minus 3 whole square. Let's attempt one more question. You have to find the derivative of this expression y 1 plus x square divided by 1 minus x square, and its whole power is 17. You have to find the derivative of this expression. Now we can see that the expression 1 plus x square over 1 minus x square has the whole power. So whenever there is the whole power, the first rule of derivative that you will apply, it would be the power rule. Since the whole power is 17, so when we apply the power rule, so power comes on the side, whatever is the expression inside the power as it is, 1 plus x square over 1 minus x square, 17 minus 1. We have applied the power rule here. Then multiply it with the derivative of the term inside the whole power, which is this 1 plus x square over 1 minus x square. And since 1 plus x square over 1 minus x square is in the form of the fraction, so for its derivative we will apply the quotient rule of derivative. How does the quotient rule of derivative work? Lower term as it is, upper term derivative, upper term is 1 plus x square, derivative of 1 is 0, plus x square derivative is 2x, minus upper term as it is, lower term derivative. Lower term is 1 minus x square. Derivative of 1 is 0 minus x square derivative is 2x. Whole divided by lower term as it is and its whole square. We can simplify this expression as y dash equal to 17 into 1 plus x square whole divided by 1 minus x square, 17 minus 1, 16, multiplied by 1 minus x square into 2x minus, and this minus becomes plus 1 plus x square into 2x whole divided by 1 minus x square to whole power square. We can simplify this expression further, which is 17 into 1 plus x square over 1 minus x square to whole power 16. In numerator we have 2x minus 2x cube plus 2x plus 2x cube whole divided by 1 minus x square whole square. So this 2x cube and this 2x cube cancel each other out because of their positive and negative sign. So we have y dash 17 into 1 plus x square over 1 minus x square whole power 16 into 4x divided by 1 minus x square to whole power square. This is how we find the derivative of this expression. Just know that if there is the whole power like this, then first you apply the power rule of the derivative. After applying the power rule of derivative, you multiply that expression by the derivative of the term inside the whole power. In this case, it was this term 1 plus x square over 1 minus x square. Since 1 plus x square over 1 minus x square is in the form of the fraction, so to find its derivative, we will have to apply the quotient rule of the derivative. And we did that, and this is the final solution. Let's do one more question. We have an expression y is equal to 2x plus 3 whole power 8 divided by 4x square minus 1 whole power 3. We have to find the derivative of this expression. We can see that in this expression we don't have one whole big power. Like in the previous question we had the whole power 17. So whenever there is this whole power on an expression, then you first apply the power rule. But here in this question we don't have the whole power. We have numerator and then there is a power, and we have a denominator and there is a power on that. So we don't have one big whole power. So we will not start with the power rule of derivative. To find the derivative, we will write y dash, and since this expression is given as something by something form in the form of the fraction, so we will apply the quotient rule. What does the quotient rule say? Lower term as it is. Lower term is 4x square minus 1 to whole power 3. Lower term as it is, and the upper term derivative. And see that upper term is 2x plus 3 to power 8. To find its derivative, this expression has the whole power. So first I will apply the power rule, which says power comes on the side, 2x plus 3, 8 minus 1 which is 7, and then the term which is inside, its derivative will be multiplied, which is 2. Derivative of 2x is 2 plus derivative of 3 which is 0, so we just have 2. Back to the quotient rule. Lower term as it is, upper term derivative minus upper term as it is. Upper term is 2x plus 3 whole power 8, and then the lower term derivative. Since lower term has the whole power 3, so first the power rule, which is 3 into 4x square minus 1, 3 minus 1 which is 2, multiplied by the derivative of the term inside this power, which is 4x square minus 1. So its derivative is 8x. 4x square derivative by power rule is 8x, minus 1 derivative is 0. So it's just 8x. Back to the quotient rule. Lower term as it is, upper term derivative, minus upper term as it is, lower term derivative, whole divided by lower term as it is, and then its whole square. We can write this expression in a simplified form. 4x square minus 1 to power 3, 8 to the 16 into 2x plus 3 to power 7 minus 24x, because here we have 3, here we have 8, 24x into 2x plus 3 to power 8 into 4x square minus 1 to power 2 whole divided by 4x square minus 1 to power 3 into 2 is 6. So this is how we apply the quotient rule of derivative. In the next video, you will see how to find a derivative of the trigonometric functions, and then we can again apply the quotient rule, product rule, or the power rule of the derivative on the combination of trigonometric functions.